today. I'm sure I'll be back in India really, really soon. But I'm very grateful to the organizers that I'm still able to deliver my talk, be it virtual. We're talking about Postgres' space in the AI world today. And your mental model of what AI is depends very much on when you were born. I'm showing my age a little here, but when I think about AI, I think about robots defeating chess masters at their game. Those of you that are older than me might think of movies like, Back to the Future, which is something that I will think of too, because it's just an incredible, amazing film. And if you were born after me, which is very likely, you'll think of chatbots like Siri or Alexa. You'll think of ChatGPT maybe. In any case, Postgres isn't likely to come up as a first thing when you think of AI, but Postgres does have a role to play, right? And which role depends very much on your organization's maturity level in terms of AI. You might use Postgres as a data source, as a source of information, to then feed to something else. One step further, you might use Postgres as a key component of an AI solution. And then you might actually enhance Postgres with AI too, or Postgres as a target. My name is Floor Drees, and I'm a staff community program manager at Aiven. And we offer multiple open source data tools such as Postgres, Cassandra, Kafka, Flink, ClickHouse, OpenSearch, on a variety of different clouds, so Azure, GCP, AWS, DigitalOcean, and we also offer a bunch of integrations like Datadog and Prometheus. I worked in developer relations roles before at Microsoft and Grafana Labs, and several other companies in the sort of open source developer tooling ecosystem. I organized DevOps Days Amsterdam and Eindhoven in the Netherlands, and I'm a DevOps Days core team member, which means that I'm also involved with organizing big global summits for other organizers. For instance, I also organize Community Over Code, which is the former ApacheCon, and which the next one will take place in Bratislava, Slovakia, in June 3 to 5. I have a bunch of energy, so I also organize meetups as well. Even this week in Bengaluru, even of course I can't be there, but my friends Nancy and Aditya are taking over, which I'm super grateful for. Regardless, we have two amazing talks lined up there by Zomato and Zeta Suite. So definitely, if you have time on the 2nd of March, definitely do check that out. It is a free event. And more learning is more better, right? All right, back to the topic at hand. Your Postgres, using Postgres as a data source, your Postgres already contains data, right? And Postgres is often the first data touch point. If you want to apply any kind of AI, you will want to do it on the data in your operational database. That's the data you're dealing with, right? And I'm preaching to the converted here, of course, but Postgres is also very easy to query and to integrate. And there's a huge library of integrations and tutorial for using Postgres with other solutions. And we've all been using Postgres not only for operational purposes, but likely for retrieving data for analytics as well, right? So in traditional AI, is we take a data set and we apply machine learning models. Today's LLMs are already capable of understanding English, how to write decent Python code, how to complete, in some cases, pretty complex tasks too, right? So now taking your company data, for instance, your customers' orders from Postgres and feeding into a model. Say that we want to build a chatbot interfacing with our customers. We can provide Postgres in sort of two different ways. We can use fine-tuning to serve the knowledge base of all of the answers to past support requests, and in our tone of voice, training it on all of the previous communication that has happened. So we would extract data from Postgres, feed it in the LLM, visualized by a folder here. Emojis are not infinite. So visualized by a folder here and then fine tune. But what if we want to contextualize the question, right? Like that's also something that we could do. So we can retrieve a customer's previous behavior to serve them the most relevant information. If we have recorded that they are having trouble with a specific feature, our answer to how does product A work can, instead of reciting the entire documentation, focus on troubleshooting that particular feature that they seem to be having a problem with. That data comes from Postgres 2. AI is kind of like a parrot in that it sort of just, recites all of the information that we have. And that can put you at a position of risk, since you might expose some private or business critical data. Like not too long ago, Google was able to retrieve several thousand proprietary data sets that OpenAI used to train OpenAI with a very single prompt and only spending $600 US. There are several stories of tricking ChatGPT in revealing things that it probably shouldn't, like the recipe for napalm. So that sort of like that risk does exist, right? So when we have in the same bucket, we have sensitive data as well as commercially valuable data, and worse yet, regulated data, which is often a combination of the two, that can put us at legal risk, right? So AI isn't very regulated yet. People are interfacing with AI using natural language, which means that you're dealing with an infinite number of use cases, and putting boundaries on that is real future work. But a good step from our side, a good first step, is to map our data landscape, differentiating between that sensitive data, the commercially valuable data, and the regulated data, where commercially valuable data could be like information that isn't technically really sensitive, but you wouldn't want to give out to your competitors either. And regulated data is where we don't only have a trust issue when we expose that, but we might actually be breaking laws. And then think about which fields in our table we can expose safely. But surely this is not the first time you think about this, right? You had to think this over when you send data to an analytics engine in order to make better informed business decisions, because we're all very data-driven. But we do need to think about what we give to our stakeholders in terms of we give them the data that they need, but to perform their task, but nothing more, to make sure that we don't expose data that we really shouldn't. There are a couple of sort of like frameworks for that, meaning anonymization. So we use IDs, right, instead of like actual human info. We use masking to obscure things like addresses and credit card information, that kind of stuff. And we use aggregation to prevent AI from recognizing a single user's behavior pattern. Note again, these are not new concepts. I'm not telling you anything new, hopefully. But then that's for Postgres, right? Like that's the tool that we have, we look at right now, but then Postgres isn't used in a vacuum, pun intended. You're using a myriad of services likely, and you might use like Elasticsearch or rather OpenSearch, because that's open source. You might use Redis, Apache Cassandra, even Oracle. I don't judge. And you will want to put a streaming platform between your data sources and your AI tool. We're using open source for this, the pulling of information and the delivering the data where it's needed. And at Aiven, we're very invested in Kafka. So let's say we use Kafka as the streaming service, as the sink basically, and then we put a layer on top, like Apache Flink, to perform the aforementioned anonymization, the masking, and the aggregation. Yeah. Then that's all well and good, but how do we make sure that we connect our Postgres to our Kafka? We can use a query-based approach where we get the changes every n minutes or seconds or whatever. Or we can use a log-based approach where we're using the Debezium connector to get and to propagate the changes to a table. For query-based, we define the query, and so we can choose to not include fields, or you could create a view on top of your data, so to make sure that you don't expose, for instance, a customer's address. In log-based, instead, everything you write to the table shows up in your wall log, and so you might be at risk of exposing data that you really shouldn't. To make sure to mitigate that, you can use the outbox pattern, which in an operational database, you have some sort of like the entity relationship schema that maps users to users table, orders into order table, et cetera, and exposing those source tables and the logs of those source tables could result in exposing too much. But with the outbox pattern, you create another table that only contains the data that you want to expose, right? So every time you create a new user, you create the new user in the user table, and you create the new user in the outbox table as well. Without the sensitive data and with all of the masking that you want in that case. And that wall log can be safely moved to Kafka, right? In Postgres, you can use the outbox pattern in two different ways. You can create a dedicated table, which is only the outbox table, with the drawback that you would store data twice. Or you can, instead of writing to a separate table, Postgres has a way to just write to the log. So you're using logical decoding messages in order to do that. And the benefit is that you don't write data twice, avoiding bloat, for instance, and maybe inconsistency. Moving on to Postgres as a part of the AI story. For a start, we store AI data in Postgres or feed AI data back to our Postgres database. Which is nothing new again, and nothing complicated like embeddings or vectors yet. But an example of this is the output of machine learning models predicting the probability of your customers churning. The output of the model would just be a label indicating sort of the engagement level and showing behavior that indicates churning. If you feed that output back into Postgres, where you have your data user data, alongside this new label, that will tell you more about what this customer is likely to do in terms of churning, not churning, right? It complements the data that you already have. Other than labels, you can have numbers, for instance, predicting how likely a customer is to purchase another product, right? And Postgres is super able to deal with labels and numbers. But ChatGPT and OpenAI and the likes, they, however, speak in embeddings and vectors, which is basically just a series of numbers, really. Pictures or text in ChatGPT are translated to a vector representation, and all LLMs do is vector similarity. So to try and understand which vectors are close to each other in terms of which are close to each other, so that they can actually answer your question. And if you'd like a primer on similarity search, I definitely recommend you watch this video from my wonderful colleague, Matt, who talked at PGConf in Prague last December about how he sorted 10,000 plus Pokemon cards using Postgres and pgvector. Super interesting talk. Definitely recommend that watch. Anyway, we talk about labels, numbers, and series of numbers or vectors. And Postgres has been able to work with vectors since a long time too. But now there is also the pgvector extension. And we have a lot of pgvector talks at PGConf India. So this is not your deep dive on pgvector, but I just do want to mention it. And through PGVector, we can not only store vectors, but we also provide this vector similarity. We can store the vector representation of a user or of an order, and then also answer the question what product is similar to another product, all within Postgres because of this. So if I want to find shoes that are similar to the ones that I like, I need to translate the image that I sent as an input to a vector, and then I can retrieve the best matching results. So vector databases are extremely performant for the query that you see on the screen, for instance. But when we are in Postgres, that query can now be part of a larger query since we have access to the rest of the data too, right? So we can filter for other columns or join with other tables. And that's really sort of the beauty of adding similarity search to the database that we're already using to store all of our other data as well. All right. I mean, you already know Postgres intimately, and you know how to handle it, back it up, how to secure it. So why would you move away, right? Like, and I included a little sort of quadrant of where all of these data services live in terms of like vector support. And so in the top right corner, you do see Postgres and OpenSearch and ClickHouse Cassandra, who have vector capabilities, right? And that are open source. And then you see to the left, you see more dedicated vector databases. And in the below corners, you'll see proprietary solutions, if that's our game, right? I don't judge. Already mentioned, an image is nothing but a series of numbers. Vector similarity allows you to store gigantic problems like product recommendations that I mentioned before. These are shoes that I like. I want to find shoes that are similar to the shoes that I like. And we can also solve very real problems, of course, like differentiating between chihuahuas and muffins. I know we're solving the real issues here. I do recommend, however, watching or looking at the Jupyter notebook that my colleague Francesco has prepared for making that differentiation and working with Postgres and PGVector if you want to start playing around with these tools a little bit more. All right. From using Postgres for vector similarity, we're moving to sort of like calculating the vectors too. Because until now, the AI bit has been very much external. So how do we use AI in Postgres? Well, any way we like, really, because there are extensions that allow us to write any code we'd like in Postgres, like the PL Python 3U library. What a horrible name to pronounce, by the way. Naming is very hard, isn't it? Or PostgreSQL for natural language task with SQL, and using tools like this, you never have to leave Postgres, and your data never has to leave Postgres. So it is kind of attractive. So, for example, if I want to figure out the sentiment of a sentence and whether that sentiment is positive, using PostgreSQL, I can find out without, again, my data ever having to leave the database. But, we're in the software world, and whether or not you should perform AI tasks in your database or not it depends, right? So thinking about this and thinking about, like whether to move your compute where your data is in Postgres or to move the data where your computational engine is out of Postgres is something to be discussed. Like there's definitely benefits and trade-offs to both of these approaches, right? So when you move your compute where your data is, there is no data movement, right? So that means that you're applying the same security settings to your machine learning as you have architected for your precious data. You won't have any stale data because you're still in the same operational database. Security, again, you don't want to overexpose data. You can reuse existing skills that are already available in your team when you're just continuing to use Postgres. As a drawback, though, you have an increased variety of workloads, which might need individual optimization, and that takes time and effort for sure. Then when you move your data where your compute is, you definitely have more choice of tooling and maybe more appropriate tooling, right? And that is maybe better than installing a bunch of Python packages in your production database, which will definitely raise some eyebrows. Then different workloads have very different computational needs, right? So AI needs a bunch of GPU, which your normal Postgres needs not. And data scientists are usually not in your database. They see it as a source, right? They extract the data, and because your tooling is in a database, you restrict them to live and breathe in the database, they will find workarounds and extract the data still, and maybe not in the best of ways. And then there is the separation of concerns. A database underpinning the most vital application that is also running AI workloads, that could be really tricky to explain to your InfoSec team. But then again, maybe not today, because all of our bosses and our bosses' bosses want AI. So maybe it is not so hard to explain after all. Moving to our last part, Postgres as the target. So while some folks might be very worried about their livelihoods with the rise of AI, and maybe rightly so, many more see AI as a productivity assistant. So ChatGPT that helps you write that email, Copilot to help you write that functionality because you're not the first to ever write that feature. That allows us to work smarter and not more. And AI can be a productivity assistant for Postgres users too. So for developers, it can help from test to query or from test to SQL. And it can help optimize queries or to rewrite SQL to optimize performance. It can help optimize writing code. And it can provide suggestions and learning, which is actually a really, really important part. And I want to stress that because we don't want to lean on AI for prosperity. We want to learn from the suggestions that it's making. And then for a DBA, you don't just manage one database, right? Like you might manage a whole fleet. And you want observability. You want to have AI listen to operation variability. You want to understand trends. You want anomaly detection and alerting, instead of you having to monitor all kinds of different dashboards. You'd be able to get performance insights from an AI where it tells you what areas might need attention, what variations might need attention. And again, these improvement suggestions to like changing parameters or how to write your queries in a better way and understand how to do that better in the future in the first place. In any case, it is very important to keep sight of that balance between sort of automatic optimization versus performance stability, in which the latter should really be your North Star. And again, I want to stress that you use AI to tune and to suggest, but make sure that an expert human ultimately holds that scale. I think that is very, very important. And following that philosophy, Aiven has recently acquired EverSQL, which is an optimization engine on top of any database, including Postgres. It suggests optimizations for a single SQL query, or as in DBA, you can attach a sensor to your database that monitors your database to understand why maybe it's slow. EverSQL also provides several free developer tools, like SQL to text and the other way around, SQL to Django code, SQL to Laravel code, and so on. And we have a code for you to try out EverSQL for an extended period of time for free. I will actually try and share that with the organizer, so that's something that you can play around with potentially if that's something that interests you. So if you want to optimize a single query in EverSQL, you select the database that you're using. You select where you're running your database. You sort of like toggle between, are you using an ORM or vanilla SQL? and that allows you the kind of optimization that you can do. You paste your SQL query, and EverSQL that will then tell you how to rewrite it, which indexes you can create in order to maybe improve the performance. And you will always have your suggestions paired with the explanation. So you can directly embed the suggestions, but you will also have the opportunity for learning, so that you know what to do better in the future. EverSQL will also show you anomalies and how to save costs and how to tune performance again. How EverSQL does this? Well, you share your query history and your database metadata, which is important, so that EverSQL can understand what you're trying to do, and then in that or optimize your workload or make suggestions to optimize your workload. It will need to know what data structure you're currently using in order to suggest something else, right? Like if that's in fact not actually working for you. But crucial is that it is your data. It's super important to EverSQL. So you also sort of like you're in charge of what you expose to EverSQL, and we talked about this before, right? So you're just as secure as the query that you provide to any external service. And there is a fine balance, right, between accuracy and confidentiality. Masking too much, there's not much for EverSQL to work with. Masking too little, you might be in dangerous territory again. So always just keep track of that sort of like balance. All right. Coming to the end, we talked about Postgres as a data source, using the data from Postgres to then perform some AI magic with. We talked about Postgres as a key component of your AI solution, and we talked about Postgres as a target. How can we improve our lives as Postgres users, and how can we improve our queries with AI? Okay, I want to draw your attention to things that are next. What is upcoming in terms of development? The open source initiative, who are the stewards of the open source definition, are also working on an open source AI definition, very much in draft stages still, but it's interesting to follow along and see where that is going. You can have a look at the latest draft and have a look through. And also have a look at opensource.org blog, because there will be a little bit more context to what they decide to include in the definition, what they decide to not include in the definition. So definitely interesting if you're interested in the space to follow this development. For me personally, because I talk a lot about AI ethics and open source sustainability, I look through these sort of draft stages of definitions and licenses. And what really caught my attention is the out of scope issue is regulating AI in terms of ethical viability. And so because that is out of scope for the definition, but I do think it's incredibly important. I want to make sure that I communicate a couple of suggestions for books that you definitely should read if you want to make sure that we don't make the same mistakes in terms of data bias and excluding people from all kinds of normal stuff just because the data that we use is very flawed, and the systems that we've been using is very flawed. So definitely recommend reading any of these books. By the way, all written by women, just saying. And with that, I want to thank you very much for your attention. If you noticed the little elephant in the snake illustration on my title slide, if you're not aware, if you've never read the book Le Petit Prince, the Little Prince, this is an illustration from that book. And for me, it's sort of like in this context, it is very much the snake is Python, right? Which we use for most of our AI stuff these days, and data stuff in general, of course, and then of course the elephant is our lovely Postgres, which is very much not dead, as you can see, but very much thriving. So AI and Postgres might be a match made in heaven, and I'm looking forward to hear about all of your use cases too. So please hit me up on any of these. You can send me an email, reach out to me on Twitter or on Mastodon, and I'm happy to hear about how you're using AI and Postgres. Thank you.